Salam all. So we are going to learn about the basics application that we are going to use for the 68K processing and programming. So the software is called IDE 68K. You can download it for free. Here you just can go to your Google and just Google the software IDE 68K software. And then you can just go to this particular website and then download it for free. So the process is normal. You just install it as per normal, and then you can run your software already. So what is important about this particular applications software? So we are going to use this software to write down our codes and to use it later in your project. But before that, you have to know that what is actually the graphical user interface for that one, for this particular, what is the important things that you need to look on. So this is what we are going to learn today. All right. So you just launch your Easy68K. Okay. So this is the by default. This is the applications that you're going to have a look. This is where you can write down your code. So by default, it has all these things. So you can see that for the first few lines written here, this is where you can put your title or your comments and everything. But all of this comment must be started with the asterisk symbol. This is actually to ignore or bypass as a comments, as the software need to compile it. All right. Okay. Okay. Let's do one thing first. So you can just remove this one, and then this one also. So I don't want to have a very messy on the desktop, on the application. So this is the software. So let's try one thing. So move.long hash is this one, $sign AABBCCDD to D1. Okay, so this is the very simple syntax that you can try, and you're going to compile this one first, but before that, let's try to save with this file first. And you just save this file to any, sorry, not this one, first this one, to any of the where you want to put, let's say for example on your desktop. Let's put a new folder for this one, training IDE 68K training. Then you put testing code. Again, save it. Alright. Then open up that one. Is it IDE 68K just now? So this is the one. So you can see that basically here, the code, this is the file that you have. So this is where you write down your codes, and this is what we understand how to write the code. But when the system need to use it on hardware, it cannot use this file. So you have to compile it to make sure that it can convert it to the machine code. So for the hardware to run it, so you can try to compile this one by hitting this play button. There's no error, so you can see that now you have two more files created over here after you compile it. So what is it that all about this thing, these two files? So the first one is the listing file. They call it listing file. So you can see that this is a listing file where you can see your code and the information of the machine code and the address of your memory where it will be saved. Okay, the next one, they call it as record file. This is the one that you're going to use it in your hardware, but unfortunately because of this COVID time, so you don't have time to do the hardware. So we are going to do it online, I mean simulations. So by the way, you can just have a look inside there. Open with Notepad. So this is the files by the numbers for this one. This is actually they call it a single S record. Basically, this is a S record file. Alright, but the most important interface that you're going to work is in this particular area. So let's try. Just execute this one, and we'll pop up another one. So this is the interface that very important for you to look at. So this is your code. This is sort of like your listing file. Just now, yes, your listing file is like this basically. And what you want to look at is what is actually all these informations you need to look at. Okay, so let's look at the diagram first when you learn in the class. Here is this one. Let's look at the so you go back to the previous slides, and when we learn about the microprocessor, inside the microprocessor there are three things that you need to remember. The first one, you call it register. The second one, they call it ALU, which is arithmetic logic unit. And the third one, they call it as a control unit. But the one that we always going to work with is basically on the registers itself. So the registers, we have three types of register inside the CPU. The first one, you call it data register. And the second one is address register, which is this one. And the third one, status register. And the last one, you call it program counter. So all of these registers have different functions. So you have to look at the functions over here, read all those things and understand that one. So it's just like a place for you to save a data, right? Especially on data register, this is the place where you are going to save the data inside here. So the data register is from D0 to D7, so it consists only 8 data registers. Okay, address register, we also have 8 data register, but one of them is called it A7, which is dedicated to stack pointer. Okay, and the third one, they call it status register, and the last one, they call it program counter. So you can see that all these things inside the CPU have 32-bit in size, where you can start from 0 to 31. They call it 32-bit, which means that you only has the size of 32-bit, 1010, something like that. Okay, same goes to the address register and point counter, and except the status register, you only have 16-bit for the case for the size of it. Okay, so the names for data register inside the CPU, they still call it from D0 to D7. So this is not the same like the names of the convention pin names over here. This is the pins. So you look over here. So this is the pins. These pins, this is the legs of the CPU. This is from D0 to D16. So it is not the same like this one. It is not the same like this one. Because this is the names for the registers inside the CPU, whereas the outside one is actually the name for the leg of the CPU. Same goes to address register. You have A0 to A7. This one, but at the outside you have the lead for the CPU is from A0. Where's the A0 here? Something you can find out from it here. A0, something is over here, I think, if I'm not mistaken. So it doesn't matter. So then you have up to A23. So for the pins, you have from A0 to A23. So the total pins for address pin is 24, and the total of data pins is only 16. Okay, this is D15, sorry. Right? So this is not the same. So inside this application, inside this software, what you are going to see is the data register is over here. This is data register. They call it, this is the column for registers, all of them. So D0, D1, D2, D3, D4, D5, D6, D7 is this one. D0, D1, D2, D3, D4, D5, D6, D7. And then for the address register, you have the A0 here, this one, A1, A2, A3, A4, A5, A6, and A7. A6 here, A7 is the stack pointer, which is divided to two areas, which is the USP and SSP, which is this one. Next one is the point counter. You also have the 32-bit in size. So this is the PC, they call it point counter. And the final one is, which is the status register. This is only 16-bit. But why? I just want to ask why. The point counter, even though it's 32-bit, it only have 8 digits over here, whereas in status register, it has 16 bits. Why? You can try to have a look first. And why also this one also, this data register and address register also the same, 32-bit in size but only 8 digits? The answer is because of all the data registers, address registers, and point counter are using hexa numbers, whereas your status register using binary numbers, which is in this number you are only allowed to have 1 or 0. Okay, so let's try to have a look what is actually between the hex and the relationship between hex and binary. So let's say for example that you have the number, draw here, you have a number 10 here in decimal, 10. Decimal is the number that we are using it every day in our daily life. So for binary, let's go for the hexa first. If you go convert to hexa, okay, let's look at the calculator here. I try to look at the calculator, it's much simpler. Hold on. Okay. Right, here, let's try to have a look over here. And you have mode 3 base. Let's go for decimal, 10. So you convert to hexa, the number will be A. This one is A in 16. To convert hexa to binary, the normal procedure, yeah, you must have 4 digits of binary. It's only 1 or 0. So for 10, so this is binary numbers, right? Okay. So for 10, the number will be 1, 0, 1, 0. Because this is equivalent to 1, 2, 4, and 8. 8 times 1 plus 0 times 4 plus 2 times 1 plus 0 times 1 is equivalent to 10 again. So go back to this one. So no matter what, from hexa to binary, you are going to have 4 digits over here. Is it the same one in your calculator? Yes. You only have 4 digits. So that's why in your software, all this number is in hexa numbers. So you just calculate how many of them. 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 4 binary bit is equivalent to 32. So it goes back to the same value over here is 32 bit. So that's why it has this one. Okay. So the next one that you are going to look at, okay, next one is the memory, which is you can see from the view over here, the memory out from. So where's the memory is? The memory is not inside here. The memory is at here. You can remember this one. So this is where you put your CPU, and then this is I just compare it to the latest technology. This sort of latest technology. So you have the memory you plug in over here. So it's about DDR memory, something like that, right? So this is sort of a RAM, random access memory, where this CPU will put or save the data at the memory for the processing and go back to CPU every time. So according to this particular theory, how big is your DDR, how big is your memory is going to be limited by the total numbers of your pins for address. So example here. Now you have up to only 24 pins. So the total size of your memory will be only go for 2 to the power 24 minus 1. So that is the size of your memory, which is around 16 megabyte. Around, which is normally this one. You can try to have, I'm not sure this calculator. Let's try. 2 to the power 2 shift power 24. Sorry. Oh, sorry, this is a binary, right? So, oh. Okay. So 2 to the power 24 minus 1. Is it correct? I'm not sure about how to use this calculator. But it's okay. You can try to have a look over here. 2 to the power 24 minus 1. Something like that. But it's okay, something like that. So I'm going to repeat that. Means that the memory here, the total memory is, the total size of memory will be from 0 to 16 megabyte. So if you put by using hexa numbers, it will be from 0, 0, 0, 0, 0, 0, up to the final number will be F, 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 F. So this is a total memory that your CPU can access because of the limitations of the leg of the address pin. So the address pin is not the same as the address register. So you have to remember that. So here, when you view the memory, it will show you the contents of the memory outside here. So from 0 to FFFF. So you can start from the address 000. So by default, all the values here is all F. And the final one will be FFFFF, right? So the final one will be here. This is the last location of your memory. So each of the memory size is only 8-bit. So F, there will be only for 1. Like for example here, FF means 1 F is equivalent to 1, 1, 1, 1. So this one 1, 1, 1, 1. So you look at over here, one size of memory only have FF, which is only 8-bit of size. So the total will be from 0, 0, 0 up to FFFFFFF. So the last one is here. So how to read the locations of the memory? You can read from, let's go for the easiest one from the beginning. So the locations of the first memory location is 0, is this one. Then 1 here, 2 here. You can look at this row, which is going to be the numbers at the back. So this is the third one, the fourth, the fifth, the sixth, the seventh, the eighth, 9. A is 10, right? So for the hex, so this is A, B, C, D, E, F, and the next one is 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. So this is how you want to read your memory in the application. Okay, so that is the first introduction for the software. So you can learn how to do the programming here on the next video. Thank you very much. So the rest is actually very the same. You can just go and explore all these things, but the most important thing what you need to do, you need to understand is what you are going to look at over here. These two things first. Okay, thank you very much. Let's start for the other one.